Okay, so continuing on in 4.1, looking at polynomials, and we did this with quadratics, right? We found the vertex of quadratics, which will either give me a max and a min, and we're going to do that and then extend it to polynomials. Often in applications, we want to find maximums and minimums. And there are two types of maximum minimums. There's this absolute global maximum over the entire function, and then there's these relative localized max and mins, which are, again, kind of peaks and valleys of my function. And so I've got my parabola case here. All right, so the first figure here is my parabola case. All right, so again, we dealt with all of last chapter parabolas. And so the parabola here has a minimum, right? It has a minimum here at the vertex. The minimum is the -6. It's the function value. That's my absolute minimum. There is no maximum because it's shooting off for forever, right? There is no maximum at all in this function. All right, it has a minimum but no maximum, and it's global, meaning over the entire function, it's the absolute smallest. So absolute means it is the single smallest value my function spits out is -6. All right, with polynomials, we're going to have more max and mins. We're going to have what's called localized and then absolutes. And so this example over here is an example of a polynomial, the second figure, figure 4.5. Right, it's got a lot more going on, right? Higher degree, you've got more complex. And so max and mins are whenever you've got peaks and valleys in my function. The peaks and valleys that aren't global are just localized max and mins. And so my localized max and mins are these. This is a local min, this is a local max, meaning localized meaning over that small piece it has a maximum, or over that small piece it has a minimum. But if I look at the entire function, right, I've got another part of the function that's either bigger or smaller than that. So those are localized, right? Those would be my local max and my local min. And so this part here, this 32.25, that's a local max. Right? It's local though, it's not my global one because there are values that are bigger than it. And then this one -3.1, again, that is a localized minimum, but it's not global. It's not over my entire function because actually there isn't a global one because these shoot off for forever. Alright, so I've got isolated max and mins at 1 and 3. I have a -3.1 and 2.25. Then if I look at my entire function, it does have an absolute maximum. Alright, this value here is an absolute. Alright, so at 12.7 it gives me my absolute max. It's the single biggest function value on my entire function. My function, this particular parabola, or not parabola, this particular polynomial, doesn't get any bigger than 12.7. Alright, so that's the absolute maximum. However, since these are shooting off to negative infinity, there is no absolute minimum. Alright, so no absolute minimum. There is an absolute maximum in that case. Alright, so we're going to look at that. Alright, so functions can have several local extrema means max and mins, but at most one absolute. So either you have one absolute extrema or none. So the answer is either one absolute or no absolutes. Alright, so you have one absolute max, or one absolute min, or no absolute max and no absolute min. Alright, so max and mins can either be localized or absolute. Alright, localized or absolute are what we're looking at. And so my first example here is, again, it's actually a 4th degree polynomial. Alright, this function has absolute max, but no absolute min. It does have a localized minimum. Alright, so these 2 points would be the location of the absolute max. The maximum is the 11. It's happened to be found at 2 locations. Alright, the maximum is 11. It just happens at both 2 and -2. Alright, but the biggest function value is 11. It's the single largest value on the entire functions. There's just 2 moments that it happens at. Alright, so which, again, that can happen. You can have absolute extrema at 2x values. It's the function value that makes it the absolute. This one has it. They didn't give you the minimum here. Alright, but it does have a local min. no absolute. Alright, because this is shooting off to negative infinity. Alright, so remember, the absolute extrema is the function value. Alright, the absolute extrema is the largest or the smallest function value over the domain. It can happen at more than one x value, like in this case. Happened twice, but the 11 was the largest value. Alright, so again, 11 was the biggest function value. It happened at 2, the x value 2 and the x value negative 2. So again, there's two locations. Alright, so the difference between absolute, relative is just another way to say local extrema. Alright, so absolute is the global, over the entire function. That's what it means to be global. The absolute maximum means that function value at C is either bigger than or equal to all of the other function values in the domain. All of them. Keyword all. The global minimum means that function value, at f of C, the function value, is the single smallest function value, smaller than all of the other function values on the domain. Again, all of them. It's the smallest. Localized or relative maximum means it's not all, it's only like a blip on the map, meaning it's near that value. So that's the difference. I have a local maximum if it is the single biggest moment near the C. Alright, it's just a little bit of a blip on my function, meaning it's got a little bit of a peak, right? And then it might get bigger later on, but it's at least peaking out at that one spot. It's got a peak there. Same thing for the localized minimum. It might have a valley, right? It goes down to a little valley. Now, elsewhere, it might get smaller than that, but at that little moment near C, right, near C, it's got a little dip, all right? And so that little dip would be my localized minimum. So absolute, entire function. Localized, meaning there's a little spot where I've got a peak maximum and a little spot where I've got a minimum. But if I look at the entire function, that's not necessarily the smallest or biggest value. It's just a local one. Alright, so we're going to look at some graphs of functions and find all of their extrema, which we can do this graphically. We practiced this last time, so I'm not going to go over it again. Remember, on your calculators, you've got a max and min key, right? When we found vertices, we went over this. You just do the same thing. So this is actually a quadratic case. Actually, I know my vertex, right? It's 3, 4. And so this would be the parabola opening down because of that negative 2 out front. It's got a vertex at 3, 4, and it opens down. Alright, so that's my function f of x, which you can graph on the calculator. Again, this one I didn't need to because I know what the vertex is. And so this vertex would be my absolute maximum of 4. Alright, f of 3 gives me out 4. And so 4 is the single largest function value on the entire graph. There are no localized minimums, localized maximum, that's it. That's the only extrema. And so there are no absolute minimums or local extrema. Right? The only thing this function has is an absolute maximum of 4. That's it. No other extrema. Right, the next one is a little more complicated. And again, I'm going to graph it here. You can plug it into the calculator. You will have to make your window a little bit big. I think you have to go max and min by 20. If you go by a 20 by 20 window should, but again, I'm just going to sketch it here and mark off sort of the important points. Alright, so here's my function. Finding the max and mins on my calculator. So there was one here at negative 119. And down here at 1, negative 13. To negative 8. Alright, and so this particular function comes up, has a peak there, actually goes through the origin, if I can draw it right. It looks like that, if you graphed it on your calculator. And And then you'd find those using your max min key, right? You go the second trace, maximum, left, right, guess, left, right, guess. Again, we did that in chapter 3, finding max and mins on your calculator. I may post a video to remind you how to do max and mins on the graphing calculator. But it is something we did in the last section. Alright, so I found those points that on my graph of this particular function. So this is my function g of x. And so now I want to determine which of these points are maximums, minimums, absolute, and localized. And so looking at the graph, this first one here at 119, that is an absolute maximum. Right, over the entire function, that's the biggest value out. So I have an absolute maximum of 19. It's found at -1. Alright, but the maximum is 19. That's the biggest function value on the entire graph of this function. Alright, then I've got these. These down here are localized, or relative extrema. The 113, this would be a local min, right? It's a valley case, so it's just so if I don't look at the entire function, I just kind of look here. That's what I mean by near the value. I have a local minimum of -13. All right, found at 1. Alright, but the minimum, the local minimum is -13. And then the other point up here, again, it's a peak. It's not the biggest peak, but it is a small peak. And so we call this a local maximum of -8, right? It's the function value. -8 is a localized maximum. It's found at the x value too. Alright, so those are localized ones. There is no absolute minimum because these are shooting off for forever in the negative. So no absolute min. Right? Only an absolute max, no absolute min. There's a localized maximum at -8, a localized minimum of -13, global maximum of 19, no global minimum. Alright, let's look at the next example. Alright, so this is the last one. Alright, so again, I'm going to just graph it for you. Alright, so I'm graphing this function for you. You could plug it into your calculator if you want to. Oops, mine's missing a negative. That should have been a -2 over x squared plus 4. It actually is, you have to zoom in. It looks like it's flat, so you have to zoom in. If you're graphing this on your own, zoom in. And so it looks like this. It's tight along the axes. There is a little bit of a jump here, and then it goes back down and goes tight amongst the x-axes. Alright, and this will be my local, or my absolute. If you find this, again, it's really small. It's at -1/2, -1/2. Alright, so again, you have to zoom in. So if you graph it, you can start with a standard window, but then you have to zoom in at the origin because it looks like it's flat. And so in order to see this, you do have to zoom in. Alright, then I find my minimum, right? You hit your minimum key, left, right, guess. You get a minimum here of x is 0, y is -1/2. And so this would be my absolute minimum of -0.5, found at 0. And that's it. That's the only extrema. There is no other extrema. There are no absolute maximums and no local extrema. Alright, the only one it has is an absolute minimum of -1/2. Alright, so those are absolute max and mins, which, like I said, I graphed them for you. You could practice graphing them on your calculator, and I may post an additional video of somebody going over, reminding you how to find max and mins on your calculator. Again, we did it in chapter 3 when we did vertices. But in case you've forgotten, I will try to post how to do that on your graphing calculator. Alright, so max and mins. Right, important that we can find those. So, stop in there.